If you know that the sine of theta is equal to 2/3, what you can do is you can recreate, or you can create your own right triangle for which this relationship is true. So you start with that. You can pick either of these angles to be theta. It doesn't matter which one because the measures are just the corresponding opposite and hypotenuse. So since the sine ratio is opposite over hypotenuse, the opposite side is 2 when the hypotenuse is 3. And so what you could then do in order to find all the remaining trig ratios, which is the cosine and the tangent for that theta angle, is you need to determine what this missing leg is. So we'll use Pythagorean theorem for that. So if we know that, we'll call it a here, a squared plus 2 squared, the sum of the squares of the legs has to equal the square of the hypotenuse. And so if we simplify what we have here, subtract a 4 and extract the square root, we get a is equal to, again, technically it's plus or minus root 5. Since we're dealing with lengths, we can disregard the negative. Okay, so we get a to be root 5. And so when we set up our cosine is adjacent root 5 over hypotenuse 3, and our tangent is opposite 2 over our adjacent root 5, which again, remember, we do have to rationalize this. Anytime you divide by a radical, it's equivalent, remember, 1 over any radical is equal to dividing by that base, or whatever's inside the radical, and multiplying by the radical itself. So we can rewrite this as 2 root 5 over 5, and that's the form that you're going to want to enter it.